So welcome. My name is Biplab, and now I'm gonna talk about my second topic, that is TCP. TCP is a transmission control protocol that works under the transport layer with a TCP header and also collecting the information going through the whole several layers of Wireshark model including IP headers and so on. So TCP is like a main protocol that holds everything. It's like a IP protocol suite, which is the important protocol that is usually used to deliver the packets from source to destination correctly at a time. So now it basically works on the three working mechanism, or you can call a three-way handshake before connecting. So I'm gonna show you by explaining the figure. So consider there is a client and a server. So client wants to send packet to the server or get connected to the server. Then the client sends a sync or flag with this packet to the server. Then the server receives the sync and then establishes the communications, and then it forwards the sync act flag to the client. So the client receives the packet, then it says that, oh yeah, we are now connected. So now the client again sends the ACK packet along with some messages saying to the server that now finally yes, we are both are connected. So now we are ready for like transmission of the data. So then the server changes some key mechanisms happen between them so that there is a secure connection, and then the transfer of files are accurate so that the bond is created, and then finally the message transfer happen, and then at the last stage they will send the fin packet uh, flag which shows that finalizing the communication and then terminating after the communication is finished. And so there typical there something some errors goes on when considering a TCP, because it usually tracks monitors each and every packet that is traveling to the network infrastructure to get to the particular destination. So there may be network packet loss. This happens due to when the sender sends too much of traffic, too much of packets on the traffic, which where the server is busy doing something, so that the server can't handle the burden, so it drops the packet and the loss happens, due to which the retransmission occurs. Because when the same scenario, the sender waits for the acknowledgement from the server, but the server doesn't respond, so it drops the packets, and also retransmission happens. Also, I'm going to talk about duplicate acknowledgement. So duplicate acknowledgement is something that uh, the sender is sending some packets but it failed and retransmit it, but also after certain time the same packets goes on falling down. Then in the server side sends the acknowledgement once only for the both, so the acknowledgement becomes the same number. So this usually cause due to a high latency in the network. So these are some errors, and now I'm gonna show you by capturing in the real life, like in a Wireshark. So how does the TCP entirely works while communicating between the sender and the receiver. So I'm gonna like load some resources from the net through a web browser called free tutorial to get the data and search some content from here, and then trace the traffic in the Wireshark. So it goes like this. So first I'm gonna like continue with it, and then I'm gonna search some content called UI in this educational material website. So after that, so I have captured some handful TCP packets. So if I want TCP packet, then I'm giving the filter TCP. So now I'm gonna show you how the three-way handshake works, and also some errors that occurs in the transmission control protocol. So I'm gonna stop. So I'm interested in that FE tutorial.se, so I'm gonna find that packet. So yeah, this is the packet. Hmm, 192 that. Okay, from where? So this is the packet that I'm interested. Okay, this is the 1.4.18.54.60 is, and this is an IP address for that particular web service, and this is my Wi-Fi network address, 192.168.43.225, which can be seen in this packet. So it's a version 4. and also Ethernet to frame and frame bytes. So transmission, I'm focused on transmission control protocol. So source port which I get a data is from 50424, and the destination port which the receiver receives is on is 443. So in the first packet, so this one, so the sync bit is sent along with the packet with some window receiver buffer size 56340 and length 0. So the sync packet is sent to the receiver, and the receiver then sends back the sync acknowledgement packet and flag. So here the flags can be seen like the acknowledgement flag is set 1 and the sync bit is flag 1, means that this is a phantom byte or ghost byte that the receiver is getting connected to the client, and the receiver is now hence telling that now we are establishing a communication. So I'm sending the acknowledgement packet which I received the byte. So the phantom byte usually doesn't mean any data is being received or sent from. So it's normally like a illusion type of byte data that is being addressed. And then finally, for the secure communication, so communication gets back. So the client again sends the acknowledgement packet to the destination server saying that now this connection channel is active. So now now in the next packet, so the source is sending some like message saying client hello, like I said before, and then with some packet length 157, and also sending an sending an packet like 174, and then 517 is the length of the particular that's sender. So then 517 data is sent, so where the segment number starts from 1 and I say that is ghost pattern, and now the relative sequence number is incremented by 1 every time it is incremented by 1. So this packet needs to be acknowledgement by the server side saying that I received the packet that you sent from, and then to and fro the communication happens. So at the sender side, so this this length, oh sorry, yeah, so this length becomes the acknowledgement, like this becomes the acknowledgement number for the receiver when it's while it acknowledges the packet that has been received. So it's shown here. So it becomes 518 because plus 1. So acknowledgement means like length of data bytes that you receive plus 1, sending the acknowledgement back to the client saying that the I got the data, so now I'm sending my data. So it's opening the channel between them. So similarly, now this sender who sends the data saying server hello, and then some key message exchange sending some length of 1420 data packet. So the next sequence number becomes 421, which is usually received by the client side, and the client acknowledgement this number so that it has received the number of bytes that is exchanged between the client and the server. So similarly, it happens like this only. So the packet is sent by either side of it, then it acknowledgement it and sends back the byte saying that now the communication is happening in between them. So I'm gonna now show you the final finished packet. So the finished packet is here. So it's saying that finalizing that it has received all the packets, so it is sending the particular source is sending back to the destination, showing that it is like the data has been received. So now closing the communication. So again it sends back from the server, and then it finalizes the data transmission, and then closes the communication. And so some errors that I would highlight on these points are these retransmission and duplicate acknowledgement. So in this, so the source 192.168.43.255 sends the packet to goes source like destination. So it's retransmitting. Retransmission is sent because this 1424, the length is very high, means that the server side is not listening to the client, because server might be handling some other stuff doing in the medium. And same, the duplicate acknowledgement occur because the same scenario it can happen, like the 66 lane means it hasn't traveled into any one of the routers, so the server is silence, is not hearing what the client is sending. So this happens, and then retransmission occur until and unless the client receives the acknowledgement from the receiver side. So this goes on. So this is some packets, and this is a reset act, which is like resetting the packet because it has dropped in some point while the communication. So these are the packets which I've seen. And then it talks about some flags. So these are the flags of the uh, uh, TCP protocol communication. The window size is given, and the window size is calculated by either the both channel or whether server or the client side when the communication is happening, and all the checksum file are there. So this is my topic. I hope you like it. Thank you, and your valuable feedback, I'll be waiting for it. So thank you.